before we can start doing some practices. Okay, so we mentioned that one of the issues that we can have when you're building an AI is when your system become overfitted. So when we talk about a system becoming overfitted, that means that you did not have enough data. You didn't have enough data for your system. And your system, you think that your system is really, really intelligent, while it's not. Sure, I'm recording. Yes, I am. All right. So you think your system is smarter, but actually your system is not smarter. It's just that your system was not exposed to many data. So we can have that is overfit. So when we overfit, it means that the model cannot generalize. So when we talk about generalizing, it means that the system is bad with new data, with unknown data, with data it hasn't been exposed to. That create a generalization problem. So overfitting occurs when the model cannot generalize or fit too closely to the training data. So we have certain training data. So basically, when you're creating a model, it means that we give the AI data, and the AI will learn from the data and create a certain pattern and create a mathematical equation, which we call a model, so that the new input will be applied in that equation, and then they're going to give us an output. Right. So I'm not too sure if this is going to allow me to draw anything.
Brother, thank you, right?
Sorry. Are you asking any question or you? All right. So guys, so this is, so let's say you are building a model. So remember, is there anybody who still doesn't know what is a model? Anybody? Before I continue using the term and you get more confused, is there anybody who doesn't understand the term model? All right, so I guess everybody understands the term model. All right, so when we created the model, so this line here represent the model and the blue here represent the data. So this model here, you can see it doesn't fit. It doesn't fit this data. We have so many data, but we look at the model, it doesn't fit. This is what we call an underfitting. So this model failed to learn features from this data. So underfitting can happen when you have, let's say you have so many data, but the model did not learn properly. So it doesn't really understand how to predict. But when you look at a good fitting, it means you look at the data and the model is fitting this data. This is a good model. But overfitting, it means the model has learned so many noise. So this always happens when you don't have enough data, right? You don't have enough data, but you are training, or sometimes you are training your model too much. It becomes overfitting. Okay? So understand overfitting occur when the model cannot generalize. It means now your model look like it was performing well. You have 90% of accuracy, but when you bring new data, it doesn't understand. The model cannot deal with that. All right. All right, guys. So now we have the second, the underfitting. You understand underfitting means that the machine, the model is too simple and cannot really capture all the pattern in the training data. All right, so I guess that is clear. That's the difference between overfitting and underfitting. So if I can break it down for you, the underfitting happen when the model is too simple to learn the pattern, and overfitting is when the model is too complex to learn not only the model, the pattern, but also noise from the training data. So what can create an underfitting problem? You have, for example, the lack of certain capacity, such as you have just a few parameters and poor features, you're gonna get an underfitting problem. So in this case now, when you're training a model, remember, when you're training a model, you have what we call the loss or the cost, which is measuring the inaccuracy of your model. So the training error is gonna be really high. Okay. So in terms of generalization, the model is really poor because the model doesn't really fit the training well. Okay, so it didn't learn enough from the data. All right. So an example of this can be when you're training a model with the wrong algorithm. So it doesn't really learn properly. So how to fix this issue? You need to increase the model complexity. You must maybe add some features, reduce certain conditions, understand? And then the overfitting problem means that the model has too much capacity, too many parameters. The training error, in the training, the error is very low. There's no error in training. You're already thinking that your model is performing well. You are happy with it, but it is a very bad model because when you're testing it now, the testing error is becoming now bigger than that. It's now bigger. So in terms of generalization, you have a very poor generalization because the model fits the training data too well, but it fails on new data. So the behavior of this model, you will notice that it learns too much. It learns too much, including some irrelevant noise. Okay, so this will happen, for example, when you have a deep neural network that you're training with just small amount of data. Okay, so how to fix it? Just simplify the model, use what we call regularization, increase your data, or use early stopping. All right. All right. So we now talking about what can cause underfitting. That's what we've mentioned here. You have insufficient features that can be an underfitting. You had enough data, but your features. So let's say, let me see what example I can give you. Okay, you want to create a system to determine between male and female. But I want to ask this question. If we're creating a system to determine between male and female by submitting to the system pictures, and the system must tell us if that is a male or that is a female. But when we're training the model, we use two features. We check the hair, right? If it's long or short, and then we check the outfit, if they are wearing a dress or they are wearing some pants. So can someone tell us, is the system gonna be, because we're not gonna have a good model, that's obvious, but is the system gonna be, are we gonna have an underfitting problem or overfitting problem? Can anybody tell us? Which problem are we gonna have? Which problem are we gonna have? Overfitting or underfitting?
So can you please repeat the question?
the question is this. We want to create a system, an AI tool that will look at a picture of a human being and tell us if it's a man or a woman. So it's a binary classification problem that we are solving there. But the features that we're going to use to train that AI, we're going to be training the AI using the hair of the people, if it's long or short, and using the outfit. What are they wearing? Are they wearing a pant or are they wearing a dress? So is the system going to be underfitted, or are we going to have an overfitting problem or underfitting problem?
I think it's underfitting.
Why? Why do you think
I
it's
think
underfitting?
because the features that you mentioned doesn't really like classify if the person is a male or a female.
Yes, that's the right and perfect answer. Despite the fact that you may provide enough data, your features are wrong. Your features, because there is men with long hair, there is women with short hair. So already those features, your feature selection is wrong. There is women wearing pants, okay, not really men wearing dresses, not a lot of men wearing dresses, but an example can be on a Friday. Those pictures were taken on a Friday. A male Muslim can be wearing that outfit that they wear, and the system will think it's a woman. So when you look at this type of data that you've used in this case, you did not provide enough features. So that is a cause of underfitting because your model is trained on insufficient features. Okay, so in this case, we're going to have an underfitting problem. Okay, so to fix it, we need to add more features and see that. All right. So another problem we can have is overfitting. Overfitting is, let's say, for example, you have, I'll give you one example. All right. The same example that we have. The same example that we have as you're trying to determine between male and female. But you put all the features, different features, but on top of those features, you even put a feature that maybe, let's say, you add something else. Let's see what can you add there. If you have so many features and some of them are not even relevant to really determining if this is a male or a female, like let's say the colors of the clothes and all those features. So you now have a lot of features that are not really necessary because the color of your clothes do not really determine if you're a male or female. So when you look at that now, you have so many features like that. Because you have so many features now the system is going to learn from all those features, and the system will learn so many noises. But now, because you have a training data, in the training data, the system is going to be very accurate because you use a lot of features. But in the real life, the system is going to be bad. So you're going to have a generalization problem. So it's not going to be having, so basically when you're training it, the training error will be really small, which means the error that you're getting when you're training, really small, and you are satisfied with it. But when you start testing it, now the testing error is really big because as soon as you provide data that the system has never met before, the system become weak. So the training data is too noisy. So how to fix it? You need to reduce the the training data, reduce those dimensions that you are using, the feature dimension. So some features need to be removed. You have methods such as regularization. Regularization means that we control how the training is being done. When we have, for example, what we call the weight and bias, the weights that will determine how the probability of a certain feature to belong to a certain class. We need to control those parameters. Okay. Another method can be data augmentation. That means that if you don't have enough data, you need to add more data. Because if you don't have enough data, you will have a wrong model. Just like you, yesterday, I mentioned how if you don't know someone, you only know a few things about them, you may judge them the wrong way. But if you have many information about them, that can help you. So a data augmentation can be a method to fix overfitting. You have putting, this is a regularization when we putting a penalty for certain values to control them. You have a dropout system. A dropout system means that you have a big neural network, but you can drop certain part of the neural network during training. All right. And then you have a early stopping. You understand that? And then you have your early stopping. So you have your early stopping, which means early stopping means that you were training your model. At the moment you get to a certain level, the error was really small, but as you take it to the next level, the error is growing. It means if you have to train your model 1,000 times, and then you realize when you train 4,000 times, it's really accurate. As soon as you continue training, it loses the accuracy. So you better just drop out, stop doing early stopping at 400 epoch. All right. So a dropout, this is what we talk about. You have the whole neural network. In training, you start dropping certain parts of the neural network. And then in testing, now you can have the rest of the neural network. All right. So machine learning can have different, we have 3 problems that we're solving. You will remember we have a classification problem, a regression problem, and a clustering problem. So a classification problem will mean that whatever problem we are trying to solve or whatever idea we have, the output of that model is going to be a value that comes from a different class. For example, I want to provide pictures to my AI, and my AI needs to determine if this is a dog or it's a cat. So that is a classification problem because there's a class of dogs, there's a class of cats. So I have provided data of dogs and data of cats. So my model had been created to classify that. So that means I am solving a classification problem. This is a classification task. So if I have numbers, I want the AI to determine between, or words, the AI to read words. That is also a classification problem because there is, if it's words, if we are using the alphabet that we have, we're only going to have 26, right? So it can only be from A to Z. That's how it's going to identify all the patterns. So there's kind of a classification there to see if this is to determine what this alphabet is, looking at maybe pictures or something like that. So that's the first problem we're solving. The second problem is regression. So regression is whenever the output of the model is a continuous quantity. So it's a value that you can't classify. It can be anything. For example, I want to create a system that can determine at what age someone is allowed to have maybe a certain drink based on historical data that I have. So it can be any age, it can be any number. So it's not really a class. You understand? So I want to determine What's the cost? So now let me say, for example, what problem am I solving if I want to look at people's age and the salary, as we gave that example yesterday, the age and the salary, and I want to see if this person can get a loan. What problem am I solving? What problem am I solving? What task is that? The data I'm using is people's age and their salary. And now my system must determine if this person must get a loan. So what task is that? Is that a classification or a regression?
I think it's a classification.
Yeah, in that case, it's the classification. But now, if I want to determine how much they can have as a loan, then it's become a regression because it can be any amount. It's not limited to a certain class. So that is the difference between classification and regression. Then we have clustering. So clustering is basically close to classification, but in this case now, with the classification problem, we already determine the features we will need, and we determine the classes we will need. But in the clustering, we don't really determine the features that we need, but we let the machine look at the data and create a certain group based on the similarities of the data. So this is the system that is used by your Netflix, your YouTube. When you watch certain videos, they start suggesting you the same type of videos because of that clustering. So certain videos, because in the first movie, one of the actors was Tyler Perry. Because Tyler Perry was in that movie, they will suggest to you other movies where Tyler Perry is acting. Why? Because of that similarity of data. So I want you will try something. You can try it anytime. Take your Instagram, go to the Instagram Reels. So as you move from the first video to the second video, listen properly to the first video and watch everything on that video. In most of the cases, 80% of time, you will find a similarity. It's either one word that was used, or it's an image, or the topic, or there is something similar. So even your Instagram reel is using the clustering algorithm because it looks at the similarity of things. Clustering algorithm is also used for user management. For example, you have, because you follow so and so, and I follow you, then they suggest me that person. So they put us in one class because of the similarity of us following the same person. So that is clustering. And now we also have one of the methods, one of the problem that is really growing nowadays is a generation. So the generation is the type of task where you generate things based on an input. So today we have all these generation. Today we can actually create a video by giving a certain text. You know what we do today with ChatGPT. ChatGPT is one of the AI that is solving, is doing a generation task. So you can say to ChatGPT, please write for me an email. Please do this for me. You understand? So these are the generative AIs. Okay, so but when we look at most of the issues that we're solving, the two major prediction tasks are classification and regression. Okay, because there is many cases or many AI are either using classification or regression, I'll say. All right, so um, machine learning, as we solving this task of classification or regression or anything like that. Now, the machine need to learn from the data in order for the machine to be able to predict future output. But that means we need to teach the machine. And to teach the machine, there is different methods that are used there. You have the first one, which is the supervised learning. The second one is unsupervised, and then you have a self-supervised learning, which is basically kind of unsupervised, but it's closer to certain features of the supervised, right? And then we have the reinforcement learning. So the reinforcement learning can actually be used as well as one of the methods that can be a self-supervised, but we've already created that penalty there. So the supervised learning means that when we're training the model, we tell the model what is the nature of the output. What does it mean? It means if I have pictures of dogs and cats, 5,000 pictures of dogs, 5,000 pictures of cats, and I want my AI, my model, to learn how to identify a dog from a cat. But as I provide data, I already told my AI that this picture number one, is a cat. Picture number two is a dog. So my AI already seen those labels. So when I have labels data, it's a supervised learning. But as soon as I remove the label, as soon as I give data to the AI without telling the AI what are those data, so without a human supervision, I am doing it unsupervised. But the self-supervised learning, it means that I am training the model on unlabeled data, which is like the unsupervised. The data are not labeled, okay? But the AI itself will generate supervisory signals or label automatically. And then it's going to continue training the rest of the data. So the self-supervised means that as I give the data that are not labeled, but the AI will take those data and generate the label. Okay, so this is like a new type of machine learning. Okay, so the term supervise means we have the supervisor, we teach the machine. That means we have the human being who are actually there to provide to the machine data by telling the machine what those data represent. But when we don't do that, we are in an unsupervised environment. And then we have the semi-supervised. When we have semi-supervised, it means that some of the data, if you have maybe 10,000 data, maybe 5,000 data, you've told the machine what those data represent, and the rest of the data, you did not tell the machine. That will be a semi-supervised. And then the last one will be what is really used nowadays in robotics and all these AI that has to do with robots, the drones, cleaning what you want, robots. So we use a reinforcement learning. So in reinforcement learning, what we do is we do not teach the machine what to do. We do not tell the machine or the model what to do. But what we do is we create an agent, which is the model, and we put it in a certain environment, and we just create a function for reward and punishment. So whenever it takes the wrong action, there is a punishment, and then it restarts the action and make sure it takes the right action. So what does it mean? It means when we, let's say you want to use reinforcement learning to create an AI tool that can buy stocks on the stock market and make an investment. So as I am training this model on historical data, right? So I look at what happened. Maybe I have data for the past 5 years of a certain stock. Maybe the stock was Apple. So I wanted to see how much was the stock of Apple 5 years ago, how much it was each month, for example. Those are the data. So I have data for each month. What was the price of the stock? So no, let me even make it simpler, right? So I will make it simple for you. So let's say, for example, I am let me see if I can if I can pull that out. Give me a second, guys. I want to have a practical example to show you how reinforcement learning can be used in different fields. So before I could show you that, so let's say, for example, I want to see, for example, I want to see I want to create a reinforcement learning model that can be able to invest on the change of the rates of the South African rand, for example. So how much was the South African rand 10 years ago? How much is going to be 10 years from now? How much it is every month? So based on historical data, based on how it was behaving before, I can easily look and say, this is the pattern that was followed before. So the past may repeat itself. So if something was growing a certain way, it may grow the same way. So now, how would I use reinforcement learning in that case, right? So reinforcement learning can be used by me looking at historical data. So give me a second. I want to show you this. So if I'm looking at South African rand, I don't have South African rand here, but it's fine. I will be looking maybe at the price of okay, so let's make sure I'm sharing the right. So now let me, because I'm not finding the South African rand, I will look at at if I have to look at, for example, investing on the euro versus the dollar, right? So if I'm looking at something like that, so basically I have this chart here which shows, if I look at the bottom there, so to get the 15, so currently one $1 represents, oh, so €1 you will need 0.16. And if I go back, we say go back, 16 of 9 is September. 16 September was 1.8 something. Okay, let me just look previous years or something like that. Let me see. This is 2025. So in April, we were here at 1.08, and then now we're at 1.16. So there has been growth. Now, I don't know about the future, but I can create a model with reinforcement learning. So I say, if I want to use reinforcement learning in this case, remember, I need a reward and punishment. It means maybe I have data from today, I collect data today until 7th of January 2024. So I have all this data. This data will be, this historical data will actually be closing of prices for each weeks, for example. So 1 week, so in total, I'm gonna have, let me just count that. In total, I'm gonna have about 90. There's about 90 prices that I'm going to have. So those are the data that I'm going to use. So those 90 data that I'm going to use, then I'm going to tell the model, I say, this is the agent that I create. So the agent will be taking some action. And there's only 2 actions that you can take. You can either buy a certain stock or a certain asset. You can either buy it or you can sell it. So there's 2 actions. So what's this model is going to do as a training? It's take action 1. It's buy. Action 2, sell. You understand? So now here's what's going to happen. Maybe it's going to take the first time it does that, it's going to buy every time. Every time it's buy, and then get here and see. Maybe I put some money and say, oh, this is 10,000 rand. And in the end of these 90 samples of data, I've lost all the money, because if I buy and it goes against me, there's a punishment. That means I'm losing something. If it goes in that direction, I am winning something. So now the model will see it's losing. It restarts again, take different actions. It loses until it can get certain actions combined together. It gives a positive output. Until it does that, then it's going to save that as the model. So you need to understand that reinforcement learning, we create an agent, we put the agent in a certain environment, and we're putting the agent in that environment, we let the agent take certain actions. And those actions will be a reward or a punishment. So which means that in any case, you create a robot, you tell it to, this robot is supposed to go from let's say in a serving bar, at the robot, the tree, there you have your yellow light, you have your red light, and your green light. So if it gets to the green light, if the light is red, for example, if the model take the action of driving, you minus 1 point. So you want to create a model, you provide 100 points, but for the model to really, for you to be satisfied, the total, when the model finish all the actions, it must be 80 points. So you are only allowing to lose 20 points. So now every time the model take the wrong action, it knows it's losing points. So the next time you restart again, it restarts training to take a different action. So that can go up to 1,000 times. So the model is learning from the same data at least 1,000 times. And every time it takes different actions. And different action will either lead to a reward or a punishment. And the model will be the best model, which has accumulated less punishment, more. Okay. All right. So that is how reinforcement learning will work. And we can have, when we have machine learning, we can have an issue with the dimension of the data, because as we increase the numbers of features, we have data that as well can give us problem, because we will need now more data, or else we can have an overfitting problem or underfitting problem. So very, very, very important. So the whole process of creating a model, it means you first collect the data, make sure the data are the right data. So if you want to create a system to determine between male and female, you can't provide data of images of dogs. The images must be human, male and female. So that's why you will need to do a data cleansing. So data cleansing is this, it means you check if all the data are the right data. If all the data are the right data, now you're gonna do a feature extraction. It means what are you gonna use in those features? If you're looking at creating a certain model, you need to know what are the features. If it's a facial recognition system, what are the features being used to train the model? So those features need to be selected. But in deep learning, the feature selections are done, can be done in certain cases automatically by the machine itself. So after the feature selection, then there's the model training. The model is trained. After the model is trained, it's tested and evaluated. If the model is not performing well, you go back and check at what point you got it wrong. Maybe you're using the wrong data, or maybe the data were not clean enough. So if the model evaluation can be good, you've evaluated your model, everything is fine, then you can deploy the model on any application, any device. So this is the process of creating an AI tool. All right. So that's how we're going to create an AI tool, by following this process. So now when we looking at this in machine learning, we have deep learning, deep neural networks. It means that we copy what the brain does. So if I tell you about a certain information, your brain automatically connects to different 100 billion cells. You get the information about, gets the information you know about what I told you. So if I'm in this class and I one thing, okay, Cristiano. If you have a friend called Cristiano, you're thinking of them. Don't, if you woke up, you're already thinking of millions. Why? Because certain information in your mind are already connected to all the new to give a certain output is the right output for this information. So the same way the biological neuron work, we will have artificial neuron. So tomorrow we're going to start with artificial neurons. So to understand the artificial neural network, where do we find this concept and how do we use them in AI? All right, guys. So this will be all for today. Any question? Any question?
So can you explain again about I just want to understand the difference between the self-supervised learning and enforcement learning. I just want to see what is the difference between the two.
Between the supervised and the reinforcement.
Yes, self-supervised. Yeah.
Are you talking about supervised or self-supervised?
Self.
Self-supervised. All right.
Yes.
So yes. So the self-supervised will basically be you, because remember, in the reinforcement learning, I'm just trying to see, okay, maybe tomorrow I'm going to show you an example of data, how data are collected. Okay, let me look at okay, let's look at something like this, right? Let me check, maybe okay, I'll just from right. Uh, so in a supervised learning, right? I have, let's say I have pictures. Okay, in this case, let me not talk about pictures. Let's say I want to see if a person is healthy or unhealthy. Based on what? Based on the age of the person, the weight of the person, and the height of the person. Feature one, height, age, and what else? What else did I say? the weight, the height, and the age, right? So this is for which sample? Sample 1. So sample 1 give us this. So in a supervised learning, when I have these features, I also give the model what was the output of that feature, which was healthy or unhealthy. So in all the data that I've given the machine, the machine already know the output, and the machine will learn from those data and see what pattern leads to this output, and then create a model so that when you bring a new input, where you're gonna bring a new person with a certain age, certain weight, and certain height, this model can be able to tell you this person is healthy or unhealthy. If you want the same scenario to create a reinforcement learning system with this, what you're going to do is you're going to create these agents. So these agents will be an agent that take certain choices. What choices they take? They take action of saying this person is healthy, and then you compare it to what you have in the data. Was it healthy or unhealthy? So if they get it right, they get +1. If they get it wrong, they don't get a point for that. You understand? So in a reinforcement learning, the data are labeled. So we know the right action and the wrong action. But the model needs to take the right action. So it learns from the right action. Think of it like a child. When you look at a child, you have supervised learning. You tell your child, do not do that, right? You give them instruction. You say, when they give you something, you need to say thank you. That is a supervised learning. So you told them the instruction before they could do it. So the next time someone give them something, they say thank you. Reinforcement learning means that you let them take the action. If they say thank you, you do nothing, or you reward them. If they don't say thank you, you slap them. Remember now, in this case, you did not tell them beforehand that the right thing to do is to say thank you when they give you something, but you punish them for taking that action. What will your child do the next time? What do you think your child will do the next time?
I'll definitely do the right thing based on
Exactly.
yes.
You understand? So think about it like an African raising the kids. You know how our parents raised us. They let you make mistake and then they punish you. That's reinforcement learning.
Now, okay, I understand now. Thanks.
Yes. So reinforcement learning is all about letting the machine make mistake and then you punish the machine and then the machine will learn from the mistakes. And supervised learning is before the machine make mistakes, you tell the machine the right thing. All right, guys. Any other question before we can close this? All right, guys. I guess this will be all for tonight. Have a great evening. I will see you tomorrow.